This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Your code is powerful, and so are you. And when you consider the reach of your code, it's clear that to deliver quality code, you must also deliver secure code. Where can you start? A first step is educating yourself on basic secure coding principles and beginning to put these principles into practice every day. Vericode's Secure Coding Toolkit is your go-to resource for all your secure coding needs. The benefits of our toolkit include learning best practices for secure coding, understanding how to secure your DevOps environments, learning to combat the most common software vulnerabilities. Stay secure and download this valuable asset today at www.vericode.com/SERadio.
Hello, this is Simon Crossley for Software Engineering Radio. Today I'm speaking with Arnon Axelrod about test automation. Arnon has worked in software engineering and test automation in several high-tech companies, including Microsoft and NCR Corporation, where he established a test automation infrastructure that was used by over 100 developers, running over 4,000 acceptance tests in less than 20 minutes. Arnon is now the lead of the test automation team at Seller Group in Israel, and is the author of the 2018 book, The Complete Guide to Test Automation, which is published by A-Press. So, Arnon, welcome to Software Engineering Radio.
Thank you. Thank you for having me.
Yeah. So let's start with a simple, high-level question. Why would we automate testing? What's the purpose of test automation?
Okay, so first purpose to automate the test is to save time from manual testing, but it's not just that. Test automation and manual testing have a lot of differences. Not everything that is appropriate for manual testing is appropriate for test automation, and vice versa. But another benefit of test automation is that we can run it very often and give fast feedback to developers, and this fast feedback helps the developers fix the code and create more higher quality code instead of just finding the bugs in the end of the process.
You mentioned that manual testing would be different from automated testing.
Right.
Have you got an example of the kinds of differences that would appear between the different types?
Yeah, so first of all, you have to remember that automated tests doesn't have judgment. They don't really have a mind, and they cannot decide for themselves if something is good or bad, if it's right or wrong. So we have to be much more precise in the way we define the test. So manual testers often describe the test in somewhat, I wouldn't say vague, but not thoroughly precise way, because they can use their judgment to know if the result is good or not. And there are specific things that are, in particular, are not very good for test automation. For example, the test automation cannot say whether the UI looks good and if it's easy to use, for example. But on the other hand, with using test automation, you can typically cover edge cases and more extreme scenarios that in manual testing it may be harder or infeasible.
The tests, they have greater precision with the automated tests. Can this lead to problems with maintenance of the test? They're going to be sensitive to change?
Yeah, sure. So because the tests need to be very precise in the way they are defined, because you have to define very specifically what's the expected result, then every little change in the application under test can require the test to be changed. Not only the expected result, it can also be technical details in the middle of the flow For example, if we're using, let's say, if we're using Selenium to automate the browser, if the attributes of the elements that we're interacting with change, then we may need to change the test also, and not only the expected result. So the maintenance and the maintainability of the test is a very important aspect of test automation.
And we'll talk a lot more about aspects like maintainability in the course of the show. If I want to begin automating some tests, who in the team should I look for? Who the right personnel with the right kind of skills to take on the test automation tasks?
Well, it depends on the team and on the people on the team and the culture of the team. It depends on many things. There are few, let's say, patterns, organizational patterns, if you will. So in some companies, they just take manual testers that may have some background in code, let them to write the tests. In other teams, they hire dedicated test automation developers. Some teams split the work between one dedicated test automation developers that only writes the common code or building blocks of the scenarios that other non-coders can use, and other teams just use the developers themselves to write the tests.
And so it's very dependent upon the skills within the organization. Are there different ways in which the teams can be split up? I'm thinking vertical and horizontal separation and how that might affect how the tests get written.
Yeah, so there's a big correlation between the organizational structure and the architecture. This is something that is called Conway's Law. It's not related directly to test automation, but also the architecture and is related to the test automation, and everything is related together. So, for example, in teams where they have full stack developers that do everything from the UI through the server side up to the database or anything, typically in these teams, if the developers would write the tests, they can cover everything together. Other groups that have several teams for different layers, for example, then it will be more natural, though not necessarily better, to have test automation developers in each of these teams to cover each of these layers.
So if I have a project which is, maybe I've got some well-established code, I've got a large code base and I don't have any test automation, how can I start introducing test automation to get most value?
I typically advise to start from the sanity tests, which should cover the more basic scenarios, but more broadly. So if you have several features in the application, then can create one or few scenarios for each of these features, but don't dive very deeply into each of these features. So this is typically called the sanity tests, and it gives the most value soon, because it can give fast feedback to developers that they at least didn't break anything in very crucial manner.
I'll be covering the most important scenarios, and so now we begin to talk about the concept of coverage, and I think it'd be interesting to think about coverage and what that is and how we might track that in our tests.
Yeah, so companies and teams that only starting with test automation, they often have this conception that will take few months and will write test automation and will replace all the regression tests that we have. In reality, first it takes very long to really get to near full coverage. It can take years. It may sound like until we didn't get there, then we didn't do our job of replacing the manual tests. But first, you can prioritize which areas of the code, which features you want to cover first. There are many aspects to this question. Basically, to do a risk analysis, but also I recommend to start covering the new features right away, or at least just after covering the sanity tests, and not wait until you covered all the regressions that you have now.
We had a recent show on code test coverage with Mark Hoffman. Talked about that on our episode 324. You talked about different ways of measuring test coverage. What other metrics might I use?
Okay, so as I said, the most common one, at least for software engineering perspective, is the code coverage metric, but is very technical measurement. Often test managers prefer to measure how many manual tests were covered by automated tests. You can also measure how many features are covered by automated tests. But then it raises the question, how do you define what is a feature, and how do you measure how much of this feature is covered? Because it's not very technical.
Okay, so the code coverage is a common metric. It's a technical measure, but I guess it's easy, and it gives you a concrete answer. Some of the others may be a bit more subjective, but might be more closely linked to
the business,
the business value.
Yeah.
And if I run my test automation project and it's successful, and I reach my complete test coverage, as complete as I choose to make it, is my project over? Do I leave it then? What do I do that if I reach that point?
Okay, so of course that you have to cover the new features as well, and typically you'll also need to change and maintain the existing tests if some features change accordingly. And as I mentioned earlier, it's better to do it upfront and not wait until you get to nearly full coverage before you begin to automate the new features, because it's much more valuable to write the tests, and it's much easier to maintain also when the tests are written alongside the features. If the tests are written after features are already implemented, then most chances are that the feature is not written in a very testable manner. It may be difficult to test it, or the test may be less effective. And also, if you find a defect which is not a very high priority defect, it's only minor or medium severity, then most chances are that it won't be given a high priority now, and it will be fixed only somewhere in the future. And in the meantime, you'll have your test failing. And while these tests are failing, it can potentially hide other defects, and it makes it harder to manage and to maintain.
To have confidence in the tests gives you confidence in the application that's under test.
Yeah, so the confidence is very, very important, and even if you have the best test automation solution, but people don't trust it and don't have confidence in it, then it's worthless. So the confidence and the reliability of the tests are very important. And tests can fail due to several reasons. Typically, there can be 4 reasons that can cause a test to fail. One is obviously a bug. This is what we're looking for, a bug in the application. But The second one is also if something in the product has changed and we need to update the test automation to reflect this change. So it's not a bug, it's change that was done by design, but the test failed because it wasn't prepared for this change. The third reason is a bug in the test automation, because the test automation is also code. It should be simpler code without many if statements and loops, but there still can be bugs that are caused by presumptions that you made when you wrote the test, and these presumptions may not always be correct. And the fourth one is things that are typically considered beyond of our control, like network failure, disk failure, out of memory or out of disk space or things like that, which are typically considered as environmental reasons.
Okay, so we've got the real bug in the code, which is the thing that we're looking for. We've got changes to code with unintended failures, problems with code, and external factors. If I've automated my tests, I might run all of my tests before my developers commit the code into my code repository, and so make sure that I don't get failing code committed in the repo. What kind of things might make that difficult to achieve?
So first, this is the preferred way. We want the test to run as soon as possible. We want the developers to run them before they commit their changes. But there can be, we need to plan our tests in a way that allows multiple users or multiple developers in this case to run this test simultaneously and won't cause failures that one test run disturbs the other. So we need to create isolation between the tests.
Do you have an example of a kind of problem that a failure of isolation might cause?
Yeah, so by the way, isolation, there are few reasons to ensure isolation. One of them is, as I mentioned, is to allow different test run to occur simultaneously. But even if you run all the tests linearly, some tests may affect other tests unintentionally, and this is also something that you have to consider and to make sure that you do the proper isolation between the tests. Some techniques for isolation may be to clean all the data between the tests, or to have separate environments, separate databases, separate tenants if you're working on a multi-tenant application, for example. Of course, things like containers and virtual machines can help ensure isolation, as long as the data is also resides on these containers.
Is it possible to summarize the goal of isolation and what it is we're hoping to achieve?
Yeah, so in isolation, first of all, it's important to ensure the reliability of the test, that no matter when and how we run the test, we'll always get the same result. If the application works correctly, or if it has a bug, then it will be reported the same if it runs on different times or environments. So this is the main goal of isolation. But more specifically, it should ensure that tests cannot affect each other by mistake, that tests may not be affected by external factors, like, for example, if the test environment is shared between the test automation and manual testers, then manual testers may be tweaking the environment in a way that can cause the test automation to fail. So this is also something that we need to isolate from.
If we take a step back and think about where I might test my application, do I run my tests at the UI layer, at the API layer? What are the options that are available for those kind of tests, and what are the pros and cons?
Yeah, okay. So oftentimes you hear people talking about the test pyramid and separate between three kinds of tests: the unit test, the integration test, and the system tests. But I think that there are much more to it than this pyramid. You need to consider the architecture of your application, which components or which services it has, and you also need to decide which scenarios you want to test, and what are the important components to be included in the system under test, and which components may cause some noise, if you will, to the results of the tests. And these ones you also want to isolate using mocks or simulators. And you can create many kinds of, I call it test scope. Test scope is the set of all of the components that you include in your system under test and which components you exclude from it. The smaller the test scope, like in unit test, we tend to test more technical things, things that are less related to the business functionality, but they are very fast, and if they fail, they tell you exactly where the problem is. On the other extreme, the system tests, for example, they give you confidence that application works as the user sees it and as the business value that you want to provide. But they're typically much, much smaller, and often they are harder to maintain. If they fail, you still need to look through the logs and other things in order to assess where the problem was.
How might I know the appropriate amount of testing to do at these different tiers? What factors might affect how I plan my tests?
There are many factors, but and there's also not one right answer. But in general, the test should cover some business functionality, even if it's in a unit test. So, for example, if you have class or a function that is responsible for some business logic, then you can test this specific class using a unit test. It will be excellent. But if the business logic that you want to test is spread across different services, for example, then you would need a broader test scope. So this is more or less the trade-off. You want it to be as small as possible, but not too technical, and always keep some business functionality under the test.
If the tests take longer to run, take longer to set up, take more data to this, then maybe I need to schedule these differently.
Yeah. So this is also one of the factors how to choose the appropriate test scope, though not the only one, and not probably not the first one that you should consider. But it also have, if you choose a test scope that is slower, let's say you decided to test it from the UI, you can still use techniques like parallelism and multiple environments in order to make them run faster. Or you can decide that part of the test will run, let's say, only nightly or even weekly, while the more important test will run continuous integration, will run immediately after the developers checked in their code.
Okay, so you've mentioned continuous integration there, which is definitely something that I wanted to talk about. The tests that run when developers check in their code. What advantages can I expect from continuous integration?
So, as I said earlier, the main benefit of test automation is the fast feedback that it gives the developers. So you need the continuous integration in order to get this fast feedback and in order to allow them to fix quickly. And Of course, we want developers to run the test even before they check in, or using something that is often called the gated check-in, which means that they check in, they commit their code, but only if the test passed, then the code really get merged into the main branch. And this helps keep the developer branch in good shape and to avoid most bugs that, as you can in the first place, instead of finding them later in the process. And if you also have high code coverage or high coverage, no matter how you measure it, of a feature, then you can easily refactor the code and improve its internal structure and its quality also. Because, and this is, I think, that one of the more important benefits of test automation and of continuous integration in general, because if we're working in an agile process, we should embrace change, and in order to embrace change, the application, the code, and the structure of the application need to change. And if we don't have big enough code coverage of automated tests, then it will be very risky to change the design of the code because we can introduce new bugs. But if we have fast feedback of high coverage, then we can do it very safely and easily and improve the design of the code as we go forward.
So earlier you talked about how writing tests at the same time as writing the code can help improve the design of the code. So do you have an example of the kind of design improvement that we might expect from doing that? In particular, I'm thinking about the practice of acceptance test-driven design.
Typically, we expect product owner to define all the details of the new feature that he wants, even though we know that it should be a very small feature in order to fit into a user story or into one sprint. But if we only leave this to the product owner, then maybe we miss some ideas that other people in the team might have, how to achieve the same goal, maybe easier and quicker. And we also miss the point of what's more important and what's less important. So acceptance test-driven development is a method in which the product owner only comes up with a problem statement as a role in order to, but without the I want and the rest of the description of the user story. And it comes with this description to the team, with only the problem statement to the team, and the team can sit together and discuss several options to solve this problem to the customer. And they should choose the most easy and fast solution that gives the most value. And in order to know that they understand each other, because one big reason for bugs is misunderstandings between the developers and the product owners and maybe other stakeholders. So when they want to ensure that they understand in the same way the solution, they define the acceptance criteria as a scenario that the user will be able to perform when the user story will be completed. And this scenario is actually a test, the steps that the user performs and the expected result. And if we define this scenario as a test, we can already write an automated test for it, even if the application under test isn't implemented yet, or the feature in the application under test isn't implemented. And then we can start, after we write the test and it fails, we can start writing the application code. And this helps us as developers to focus on the goal of the user story and don't develop many things that we think that we might need in the future, but we may also won't need them. So we develop only the minimum that we need right now, but if we'll need to improve this feature, because we only took the simplest solution that we could deliver fast, so we probably need to enhance this with other user stories. And when we'll develop other additional user stories in the same manner, we'll also probably want to improve the design and not only add the feature on top of the code as it was written for the first user story. So we'll refactor the code and enhance it and make it, the code of the application under test should be made more generalized, more generic, and this also make it easier to add more features in the future. So we constantly refactoring the code to improve its design, and if we made this process of acceptance test-driven development from the start, or we caught up with the development and then we continued doing it, so we have near full coverage, then we have full coverage of test automation, which the tests are very valuable, very easy to maintain, because they describe the business scenarios and not only technical stuff, and we have full coverage. And as we talked before, the combination of high coverage and fast feedback help us refactor and reorganize the code and improve it.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. DigitalOcean stands out from the crowd due to its simplicity, high performance, and no billing surprises. Join a community of over 3.5 million developers on DigitalOcean. Sign up with a free $100 infrastructure credit at do.co/SERadio.
This sounds like it should be a very powerful technique that would enable efficient communication amongst different stakeholders on the project. And it sounds wonderful, and in practice I've found it really quite difficult at times to get that to work effectively. There are various different tools that are available to help with this. I mean, are you able to talk about the tooling and how that might assist with writing acceptance tests and using those to do acceptance test-driven development?
Yes. So before I talk about the tools, first of all, I also found it pretty difficult to assimilate in organizations, but also I have experienced working in this way, and I know how wonderful it is. I guess that it's mostly a matter of culture and of mind shift. It's changing the state of mind. And it takes practice to write the user stories correctly and to define the acceptance criteria correctly. It takes a lot of time and practice to get it right. And if you don't make it right, then its value maybe is not so apparent in the beginning. So also, most projects don't start this way, and they start creating test automation after the project is also already in its middle of its life, let's say, and then it's harder to get the benefit of at least of the high coverage and of the refactoring. Now, regarding the tooling, Cucumber and SpecFlow, which is like Cucumber for .NET, are the most popular tools for this. They allow to describe the acceptance criteria or any test in like in English sentences, using only a very generic format of given, when, then. and associate each of these sentences with a method in the code which performs some action. These tools are great, and they help to apply acceptance test-driven development, or they don't force you to write good tests and to do it really before you implement the code. So it's not sufficient to use these tools in order to use this practice. And also you can get most of the benefits of ATDD without these tools, because if you write the acceptance criteria, let's say using a Word document or anything like that, and then implemented it in code, you just need to some way maybe to keep the description and the code to reference one another. But if the code of the test is written in a readable way, you can write the test code in a way which looks very much like English and like these sentences. So it's not that big of a deal. And these tools also sometimes they have their own challenges. So it's good from one hand because they make a good documentation of the test and of the features of the application on one hand, but on the other hand, they may be a little bit more challenging to maintain. But all in all, you can use it or not as you like.
So let's talk about test failure. If I get a failure in my system, and we talked earlier about how a breaking test is something that needs to be acted on straight away. Where should I start with investigating test failures?
Okay, so you should start from the failure message. For example, if you have an assert statement in the end of the test and you see expected 3, actual 2, this is where you start. But usually, if there's also an exception, not of the assert, if the test failed on an exception somewhere in the middle, then you also have the failure message and the stack trace. This can be very helpful, and you start there. If it's not enough, then you add log. You're writing steps to the log, and you can also add things like screenshots and page source in case of Selenium, and maybe the logs of the applications. And you gather all the data that you need in order to investigate the failure until you pinpoint the exact reason. At first it can take some time and be like an iterative process to improve the insights that you can see into your application and what happened. But over time, when you add these methods, you can use them over and over again, and it makes it easier to understand what happened. And this is as long as the failure is consistent, which is the easy part.
Okay, so have you got some strategies to help in those troublesome situations?
Yes. So the solutions are may not be a silver bullet that you can very quickly find the result. It can find the root cause. It can take time, but you can follow a strategy that will help you get there faster. So first of all, we need to try and make this failure occur as often as possible, which is sometimes looks a little bit counterintuitive. We tend to solve the problem without knowing exactly what happened, and we'll say, oh, if we do this and that, maybe this problem won't happen. And if we reduce the frequency of this problem, then we only makes it harder to investigate. So we need to take this unstable, this so-called flaky or flickering tests and run them as often as possible. We can run them in a loop, and we can even try to write a dedicated test that will perform the problematic operation in a loop in order to gather more information about it. And as we said before, we add logging and everything that we can to collect more evidences regarding this failure. We may add specific logs just for this particular problem. And we try to narrow down the scope of the problem. As we narrow down the scope of the problem, we can write a smaller test in a loop, a smaller and faster test, and then we can narrow it down more quickly. So, for example, if something happens only, let's say, 1 out of 10 of the cases in average, if we'll run this test, let's say, 50 times, then it's from something that we can say that it's not reproducible, it becomes something that is almost very close to 100% reproducible. The chances that the bug won't happen in 50 runs if it has a 10% chances to fail is very, very low. So now the test is reproducible, the bug is reproducible, and even though it may be long to run, we can start to analyze and to reduce its scope until we pinpoint the problem.
So strategy is to repeat the problem, make it fail as often as possible, and then reduce the scope and make things more and more specific until hopefully you can solve the problem. In the book, you mention some organisations may choose to look at a problem that's maybe, say, failing 1 in 10 times and say, so if it fails, I'll rerun the test, then if it passes the next time, then it's okay. Why is that not a good strategy?
So it's not a good strategy, first because, as I said, we want this failure to occur more often and not less often in order to be able to investigate them. But unless we really investigated the failure, we cannot assume anything about its root cause. And it can definitely be a bug and not only an environment problem, which is a very general term that many people hide things behind it. And we want to know about these problems and to fix them. If it's in the test or if it's in the product, we want to fix them so they won't happen again, because they hurt the reliability and the confidence that we have in the tests. And if today we do one retry after it fails, and it may be enough. Maybe in the future it won't be enough, and we'll start to run each test 3 times and only take the third time if it passed, and it misses almost the whole point of the test automation, which is to find the root cause of failures and not to just say, yeah, everything is great. Or to find the easier bugs.
So it's telling you that there's a problem, so you should investigate it rather than ignore it.
Yeah.
We've talked mainly about unit tests, system tests, end-to-end tests, acceptance tests. Non-functional testing can also be automated. Can we talk a little bit about approaches to automation of non-functional tests?
Okay, so there are many kinds of non-functional tests. The most common ones are performance tests and load tests. Performance tests are somewhat related and somewhat similar to functional tests, but they also measure the time it takes to complete various operations. The main difference between functional tests and performance tests is that you need to gather some statistics about the actual performance, because performance, it's not something that is very deterministic. You can say that this action always completes in 3 seconds. It can be sometimes a little bit less, sometimes a little bit more. So you need to get some statistic and to define your acceptance criteria or your expected results of the performance also in terms of statistics. So let's say I can say that 90% of the time I want this operation to complete in less than 3 minutes, and in the rest 9%, let's say, it's okay if it's up to 6 minutes, and I'll ignore the 1% that left out. So you also need to control the environment where you run the tests in order to get consistent results of the performance measurements. This is also very important. So this is performance testing. And there's also something related but pretty much different, very different, which is load testing. So in load testing, we verify how our system behaves under load, which is when many users use it simultaneously. Usually it affects the memory footprint and the CPU consumption and maybe other resources. So here we also need to define what we expect. When performing load tests, the UI layer is typically not relevant because the load happens on the server. So there's no value in making this as UI tests. Sometimes we can do it just to reuse our existing test, but it's less valuable. So in load test we simulate many concurrent users that run simultaneously and use the system on the same time, and we measure these characteristics of resource usages, and we also typically test the performance under load. So how much time it took to perform an operation under load, because if we're not under load it may take faster, but if we're under load it may be slower.
Are there tools or techniques that I may use to apply that load?
Yeah, so there are many tools in this area. The most popular one is JMeter, but there's also one inside the Visual Studio Enterprise. I know that there are other tools, but I don't know them very, very deeply.
I wanted to just touch on testing of AI routine. It's not necessarily deterministic.
Yes.
How can we approach testing in these scenarios?
So, first of all, I recommend to separate these algorithms, these machine learning heuristic algorithms from the rest of the system, and because there are different techniques to test the rest of the system which uses the AI part, and testing the AI part itself. Testing the AI part itself is, I think it's pretty well known for people who use it. They always take the data, the training data, and they split it between the training data itself and the test data, and they use the test data to validate the precision of the learning process. And the rest of the application is tested in regular means of test automation, where you just mock the UI parts. This is the most effective techniques. Sometimes you can take, if you do want to test everything end to end, like a system test together, you can use, let's say, very trivial examples that you know that the machine learning algorithm will always identify them correctly in order to test the entire system end to end.
I think that's really good advice there. Going back to your early point about scope, take the non-deterministic, the heuristic element out of scope for most of your tests. Let's think about wrapping up now. What can people do to improve their test automation and QA and programming skills in this area?
As we mentioned before, the maintainability of the tests is very important, and very important skills that is clean code and refactoring techniques that we also touched upon. And these are things that I think that all developers and certainly test automation developers should improve. And also, I don't think that we'll go into details now in the show, but in the book, in the chapter about continuous integration, it's there's a hidden gem there, which is how to. There are tips of how to improve your organization, how to take your organization even if you're just a simple test automation developer or any other role, not a manager, how you can help your organization advance to higher and higher levels of taking more and more advantages of test automation and improving the quality.
I also loved the final words of your book with share the tools and the skills and don't forget to enjoy the practice of test automation. So that was really good. So Arnon, thank you very much. It's been great to have you on the show.
Thank you.
For Software Engineering Radio, this has been Simon Crossley. So thank you for listening.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SE-radio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.